Hello and welcome back. So today we're going to be talking about uniform acceleration. So uniform acceleration is the change in velocity by a constant amount or an equal amount with time. So if we have a bus that is increase in speed, so let's say at 0 seconds that bus 0 meters per second. At 1 second, it increases to 3 meters per second. At 2 seconds, we have that it is at 6 meters per second. At 3 seconds, then we have 9 meters per second. So from what we can observe, there's a gradual increase, there's a constant increase in the velocity. So each second, the velocity increases by 3 meters per second more. So we can say that the velocity of the bus is increasing by 3 meters per second every second, which gives us an acceleration of 3 meters per second squared. So let's draw a graph to visualize it a bit. And this would be a velocity time graph. So we have velocity at this axis, and we have time in seconds at this axis. So if the line comes from there, that means we have a uniform acceleration starting from rest. So starting from the origin, this part would be 0. We can also have this, where it doesn't start from rest. So we get an initial velocity that isn't 0. So I'm just going to label my axis again. Seconds. So those are the two scenarios we usually get. But this part would be the slope. This part under it would be the distance covered. So the area under the graph is the distance, and the slope is the acceleration. And the slope acceleration. So now we know we get what uniform acceleration is. We would then apply them in the equations of motion. So the equations of motion are used when we have uniform acceleration, which is why we talked about them earlier. So I'll just write the variables first that we're going to use in the equations. So we start by saying u is the initial velocity. V would be the final velocity. A is uniform acceleration. T is time. And S is distance or displacement. So, from the definition of acceleration is the change in velocity with time. So, we can write that as A is equal to V minus U, change in velocity over time. So that is the final velocity minus the initial velocity over the time t. And then we can cross multiply. We get V minus U is equal to AT, and bring U over to the other side. We have V is equal to U plus AT, giving us our first equation of motion. For the next equation of motion, as I said earlier, the area under velocity time graph would be the distance. So let's say we had this, U here, V there. At that time, it would have t. So the area under the graph is the distance. So to find that distance, we can use the area of a parallelogram. So basically, this part is the v, this is the u, and that's the t. So area of under a parallelogram, we would take this, I'll just use red, we take this and this as the sides, and this as the height. So t is the height, and A and B, which are the sides, so U and V. So the area of a parallelogram says S, which is the area under the area of the shape, is half A plus B multiplied by H. So S would be, and we'll continue here, half A plus B is U plus V times HT. So V from the previous equation was U plus AT. So we can substitute that in here. We get half U plus AT multiplied by T. Then we get half. That'll be 2U plus AT multiplied by T. We get 2UT plus AT squared. And so S would be equal to half. S would be equal to 2UT divided by 2 would give us UT, and AT squared divided by 2 would give us half AT squared. So that makes our second equation. For our last equation, we simply use the previous one we derived. The V is equal to U plus AT. Then we square both sides. Okay, so we squared both sides, giving us V squared on this side, then U squared plus 2UAT plus A squared T squared. So if we look at this part, we see something similar to the S equals to UT plus half AT squared equation. So there we can actually factorize out. So we get U squared. So what's common between them? We can factorize the 2 and we can factorize the A. Although the 2 isn't common, we can say it would, factorizing it out would give us the equation we're looking for, which is the UT plus half AT squared. So we can factorize the 2 and the A, leaving us with UT plus a half, because this 2A multiplied by this would be A, which is what we wanted here. So see, plus half A T squared. And this is the same as S. So S is equal to UT plus half AT squared. Then we can then say V squared is equal to U squared plus 2AS. So that's our third equation of motion. So in summary, uniform acceleration is the change in velocity by a constant amount with time. So it's also known as constant acceleration. And the equations of motion are 1, V is equal to U plus AT, S is equal to UT plus half AT squared, and V squared is equal to U squared plus 2AS. So I hope this was helpful. If you didn't get anything I said earlier, or if you have a question, you can leave it in the comment section below and I'll get to it as soon as I can. Thanks for watching.